Hello friends, today we are going to discuss the factorization method of solving a quadratic equation. But before that, I would want to know from you whether you have been able to understand all these 11 expressions which were given to you in this particular exercise. You have to identify whether a particular expression is a quadratic equation or not. And I hope you have gone through this particular exercise. Expression number 1 is very simple. You are comparing it with ax square plus bx plus c is equal to 0, and you will find it out that it is basically a quadratic equation. As far as expression number 2 is concerned, here b's value is minus 1, because you see minus x. Minus x means if you compare it with bx, actually b will be equal to minus 1 and c will be equal to minus 6. If you look at the third expression, you would find that there is no x term, which means b is 0. If you look at the fourth term, you will find that there is no x squared term, which means a is equal to 0, and you know that if a is equal to 0, then it certainly cannot be a quadratic equation. So this particular expression is not a quadratic equation. As far as fifth is concerned, slightly different. Here the expression is in y. This is a quadratic equation in y. The first, second and third ones were basically quadratic equation in x, and fourth one was basically a linear equation in x. Linear equation is one in which the degree or the highest power is 1. But in fifth, you see that it is basically a quadratic equation in y, and that is why you are instead comparing it with ay square plus by plus c is equal to 0. Likewise is the case for sixth, wherein the equation is in y, so it's a quadratic equation in y, and you find out that you'll have to rearrange these terms. 6 minus y square is equal to 0. You can rearrange it, so you can write it like this: minus y square plus 6 is equal to 0, and this way you'll understand, comparing it with ay square plus by plus c, that a is equal to minus 1 and there is no b is equal to 0 because there is no y term, and c is equal to 6. So this again will become a quadratic equation. Seventh one is also quadratic equation in y, but here b and c both are 0. Eighth again is a quadratic equation. However, here you will have to do what? You will have to rearrange the equation, because you have to compare it with ay square plus by plus c is equal to 0. So what will you do? You will bring 16 to the left side. So when you bring it to the left side, it will become minus 16. Whenever some particular expression, some particular term moves from the left to the right or from right to left, the sign changes. Since the sign of 16 was plus on the right side, when it is shifted to the left side, it would become minus. So y square minus 16 is equal to 0, and when you compare it, you will be able to understand that a is equal to 1, and there is no b, there is no y term, so b is equal to 0 and c will be equal to minus 16. As far as the ninth expression is concerned, the highest power is 3, y cube, which means that it cannot be a quadratic equation, it can be a cubic equation. Cubic equation is one in which the highest degree is 3, in which the highest power is 3 or the degree is 3. Degree is the highest power. So basically linear equation is one in which the degree is 1, quadratic equation has a degree 2, and cubic equation has a degree 3. If you look at 10 and 11, what you'll have to do here is you'll have to actually multiply the two terms which have been given, x plus 2 and x plus 1. You'll have to multiply them. So how do you multiply? X from the first bracket will be multiplied with x and 1 from the second bracket, and then 2 from the first bracket will be multiplied with x and 1 from the second bracket, and this way the equation would be x square plus 3x plus 2. Please note it down and cross check whether you have also got the same answer. X square plus 3x plus 2 is equal to 0, and when you compare, you will be able to get the values of a, b and c. Likewise, in the 11th expression, again you will have to multiply, but this time you have to be aware that there is a minus sign, which means you have to be cautious of this minus sign also. You have to take this into consideration. So basically, when you multiply x square minus x plus 2x minus 2, and this will become x square plus x minus 2. X square plus x minus 2. This is how this particular equation would look like, and when you compare it, you will get the values of a, b and c, and these 2, 10 and 11, they are also quadratic equations, right? I hope you are okay with this. Let me do one thing for you. I'll do this multiplication for you here. X minus just x. There are x. The first term is, I'll do the 11th expression for you. The first term is x plus 2. Have a look at the right corner of your screen. Multiplied with x minus 1. To bear with this, we as of now do not have access to better technology. So now this x multiplied with this x will become x square. Then this x multiplied by minus 1 will become minus x. Then this plus 2 multiplied with this plus x will become plus 2x. And then this plus 2 multiplied by this minus 1 will become minus 2. And when you solve this, x square, and this one was basically minus x square, and then x into minus 1 minus x, then plus 2x and minus 2, it will be equal to x square minus 2, right? So when you compare it with ax square plus bx plus c, you will find that a is equal to basically 1, b is also equal to 1, and c is equal to minus 2. I hope you are able to understand this. So this is how you have to basically simplify. Okay then, so let us now move forward to what we have to discuss today. We have to discuss the factorization method, and I'll give you the method in the step-by-step fashion. Please understand this method. This is just a repetition of what you probably would have done in your senior, second year classes. The first step is, suppose this is the equation that you have to solve. Now, what is the meaning of solving an equation? Meaning of solving an equation is you have to find out the value of x, and since it is a quadratic equation, there would be two values which would satisfy x, and you will have to find out the two values. So if somebody tells you solve x square plus 5x plus 6, what he means is that you should solve the question and should find out the value of x. So the first thing that you have to do is multiply the terms having x square with the term not having x, or the term having x naught. Now what is x naught? I'm sorry, x raised to the power 0. X raised to the power 0. Anything raised to the power 0 is always equal to 1. Is it okay? We have discussed this earlier also. So basically the term which is not having x, because there actually x is there but the power of x is 0, so x raised to the power 0 becomes 1, and that is why there is no x, because actually x was there and it was raised to the power 0, and x raised to the power 0 is equal to 1, so basically we do not find any x there. So basically what you have to do is you have to multiply these two terms, x square and the one which does not have any x, or let's say the one which has x raised to the power 0. Now this term, while you are doing this, you have to be cautious about this sign here. The sign here is plus, and that is why it is not shown, and the sign is plus. You have to be very cautious about the sign, because the multiplication would also depend on the sign. So here, since x square was positive and x6 was positive, and we multiply them both, it will be 6x square. Now in the second step, what you have to do is you have to factorize the coefficient of the term obtained in step 1. Well, the coefficient of the term obtained, I told you what is coefficient, what is there with the variable. For example, in this particular term, 5 is the coefficient, right? In x square, what is the coefficient? Can you guess? Yes, it is basically 1, because x square means 1x square. That is why no 1 has been mentioned. The coefficient here is 1. So This second step says that you have to factorize the coefficient of term obtained in step 1. So this is the term that you have obtained in step 1, 6x square, and the coefficient is this 6. Is this okay? So this 6 is the coefficient, right? So what you have to do now is you have to basically factorize it. Factorize means you have to find out the factors and you have to find out the prime factors. So I have factorized this 6 into 1 into 2 into 3. You could have skipped 1, but here we mention 1 because 1 might be of some assistance to us when we are doing the factorization and when we are proceeding with solving the question. We are proceeding to solving the question. There 1 might come in handy, so that is why I have mentioned 1. Without 1 also 2 into 3 is always 6, but I am still mentioning 1 because it might be of some use later on. So this is how you factorize the coefficient which we had obtained in step 1, and now we have got 1 into 2 into 3. Now let us find out what is the third step. The third step is that you have to split the term having x into 2 such that the product of these two is same as the product obtained in step 1 above. Now let me make a small correction. Here, into 2 such better. Now this is more comprehensible. So go back to the PowerPoint mode. So you have to split the term having x into 2 such terms that the product of these two is same as the product obtained in step 1 above. So let us understand this phrase by phrase. Split the term having x. Now where is the term having x? This is the term having x. And you also have to worry about the sign. So basically x, right? So this is a term having x, and you have to split, you have to break it down into 2 such terms that the product of the 2 terms is same as the product obtained in step 1 above. So the product of these 2 terms in which you break down 5x should be equal to this 6x square plus 6x square, right? So what I'm doing now is I'm trying to break down 5x into 2 terms and then I'm testing their product. See, 1x and 4x. 5x can be broken down into 1x and 4x. 1x plus 4x becomes 5x. So perfectly fine. But what would be the product of 1x and 4x? 4x square, right? But what we need is 6x square. But since we are not getting it, we have to look for some other way of splitting the middle term. Right, now we have done it in a slightly different fashion. Now 6x minus 1x. Now have a look at this. 6x and minus 1x, there are the 2 terms in which you have split 5x. 6x minus 1x is equal to 5x, so perfectly fine. But the product would be 6 into minus 1 is minus 6 and x into x is x square. Again, this is of no use to us because what we want is plus 6x square. You have to be very much cautious about this sign that precedes a particular term here. So the sign is plus 6x square, but what we are getting here is minus 6x square, so that is not going to do. So now let us have a look at another option. So we'll have to keep on testing the various options that come up. Now 5x can be broken down like this also, 2x and 3x. When you add 2x and 3x, the sum is equal to 5x, so that is perfectly fine. What about the product? 2 into 3, absolutely fine, and x into x equal to x square. Plus into plus is plus, which means it is positive 6x square, which means you have got what you wanted to. You had to split it into 2 terms. We have done that, 2x and 3x, such that the product of these 2 terms, which is 6x square, should be equal to the product we have obtained in the first step, right? So now let us move forward. So we are moving ahead with this. See, we have got what we wanted. Now we are moving ahead with the solution. Step 4 would be to replace the term containing x by split terms and proceed as shown. So this term, this plus 5x, now will have to be replaced by the split terms. Now what do we mean? And along with their signs. And now we have to proceed in the manner in which it has been shown below. So now what we have done is we have actually square plus 5x plus 6, the middle term or the term with x in it. So 5x has now been split into 2x and 3x. Have a look. And plus 6 is equal to 0. Now please don't think that we have made any change to the equation. The equation remains the same. Why? See, x square, this 6, this 6 here, and then what about this? Plus 5x, and if you add these two up, it would again be plus 5x. So you are not making any changes to the equation. The only thing is you have basically split the one into two terms. That is all what you have done. So you have not made any change to the equation as such. The equation still remains the same, right? Now we have replaced the term containing x, which is this one, with 2x plus 3x, which we had obtained in step number 3. And now what we are going to do next is we have to group them in a pair of 2. So we have grouped the first two terms and the second two terms. Now this circle shows basically the grouping. So we have now basically the groupings like this, and then what we do in the next step. Now in the first grouping we take out whatever we can take out as common. So what is common in x square plus 2x? You would find that x is common. So we have taken out x. What remains inside is x. When you take out x, what remains inside this one becomes x, and here since x has been taken out, what remains inside is 2, right? In the second group also, second pair also, we have to take out whatever we can take out. So here we have taken out 3. So 3 has been taken out, so what will be left inside x? And then since 3 has been taken out, what is left inside is 2. Is this okay? If you are still not able to follow, then what you will do, if you are not sure that you have done it in the right manner, you can go in the opposite direction. What you do is you start multiplying this. You should get this. So x into x is x square, perfectly fine. X into 2 is 2x, perfectly fine. 3 into x is plus 3x. 3 into 2 is plus 6, which means you have done it in the correct fashion, right? Then what you do now is, since you find, and now this is an indicator that you are moving in the correct direction and you are doing the question without any error. The error may still be there, but this points to the fact that their chances of error are much less. If you get the same term here as well as here, this to an extent can be an indicator of your proceeding in an accurate fashion. So what you'll do now is, since you have got the same term here as well as here, so you take out x plus 2 as common. So this is what we have done here, and what is left inside would be x plus 2 taken out. So what will be left here would be this x, and what would be left here would be this plus 3, and that is what we have done here, x plus 2 and x plus 3. So now we have been able to basically convert this equation into x square plus 5x plus 6 into this form. Now if it has to be 0, equate each of these two terms thus obtained to 0. Why we are doing this? Because x plus 2 and x plus 3 is equal to 0. So it could be that x plus 2 is equal to 0, right? This is what we are doing. X plus 2 is equal to 0, because anything multiplied with 0 would be 0. So in this particular expression, x plus 2 is equal to 0. Why it can be x plus 2 is equal to 0? Since if any of these two terms, the two terms that we've got here, if any of these two terms is 0, then the result would be 0. That is why we are saying x plus 2 can be 0. In case x plus 2 is 0, then again you change the side of this particular term. You'll find when 2 moves to the right side, the sign would change, plus to minus, and x will be equal to minus 2. And likewise, the next term also can be assumed to be 0. X plus 3 is equal to 0. So again, when 3 moves to the right side, the sign changes. So these are the two possible values of x in this particular equation, and this is the solution for this particular equation. So now we have solved for x in this particular equation, x square plus 5x plus 6. Now how do we check it? See, checking is pretty easy. What you can do, you will have to put in these values here. So first put minus 2, here in this original equation, and you are able to get the result as 0, then yes, your solution was correct. Likewise, you have to test for -3, put this again minus in this equation, and if you get the result as 0, your solution is absolutely correct. This is fine. So the task for you today is to go through this particular discussion, and if you are not able to understand any particular aspect, please pause the video and listen to that particular section again, and in the forthcoming sessions we'll start taking more examples to make you understand the factorization method better.